to present our first keynote speaker, and Dr. Panmao Zhai. Professor Zhai is a chief scientist at the Chinese Academy of Meteorological Sciences, and he's an expert on extreme events too. And at the moment, he's also one of the co-chairs of the IPCC Working Group 1 on climate change. So the word is yours, Professor Zhai.
Thank you, Deliang. Good afternoon, everybody. I'm very glad to have the chance here to exchange our recent study on changing of climate extremes. So my talk today will be more focused on changing of the persistency of the extreme precipitation. Although the title is changing frequency, intensity, and frequency, but I will more focus on the durations, the persistency, because we all know current status on precipitation extreme studies. We have a substantial attention on changing the frequency and the intensity. But for multi-day extreme precipitation, see, we have some understanding about some 5 days total, but we have less attention on the changes of the persistent extreme events. Or the 5-day total, you can see some days you don't have rainfall, some even not saying about the extreme event, and like a monthly total. But today here, my focus will be more on the persistent extremes. And the question is there any possibility of changes in the duration-based structure, or if there is any change, why? And also for this IPCC session cycle, in this cycle, we notice we have more and more requests want to ask for the regional information. We know temperature change, they have the global scale, because impact directly linked to the global warming, the greenhouse gas effect. But for rainfall, always modulated by the circulation, so it's more complex. But rainfall will bring us a lot of water resources, also will bring us a lot of disasters. So today's talk is, the first part is look at the persistent and the non-persistent extreme precipitation changes. And the second one will how they link to the large-scale circulation patterns, how they change. And the last part I will give a more specific case to look at the change in Southwest China. And it is, focus on changing extreme precipitation in China, because China, we have a lot of observation data, more than 6 years. We have daily data, more than 2,400 stations. And then we look at, the first figure is the annual, the trend in the annual precipitation total. You see most of the China precipitation is increasing, but in two parts. One is North China, another Southwest China. They are decreasing. And this year's contribution of the extreme precipitation, although only 5% of the rainfall, the top 5%, but the contribution to the total, say, over than 30%. In northwest part of China, which is a very dry area, you see more than 70% of the rainfall come from the extreme events. And then we look at the trend in the extreme precipitation. You see here, most area it's increasing. Only in North China, southwest part of China is decreasing. And this is changing based on the absolute the value. If you change by relative rainfall, you will see a lot of increase in northwest part of China. And say this is a contribution of extreme rainfall to the total. You see also most of part of China is increasing. That means in China's rainfall change is mainly dominated by the changing the extreme event. And only you see the pattern, only two places, one is North China, another Southwest China, it's decreasing. But most of other parts is increasing. And these two figures showing one is non-persistent extreme precipitation, the trend, because non-persistent is only have single day rainfall. You don't, the next day that's stopped, not continue. But the other parts is mainly the consecutive one. So you see here, the patterns, the trend patterns are very similar. You see most of part of China increasing, especially southern part of China, which is a well-developed part of China, and only in north part of China and the southwest of China, say persistent extreme and non-persistent extreme precipitation all decreasing. Other parts is increasing. And we look at four different specific regions. One is North China, Southwest China, which one is here, another is here. You see there are different ones. One is rainfall total, another extreme, and one is all the changes of extreme rainfall total. Then one is for the non-persistent one, another is persistent one. You see, namely, for North China and the Southwest China, they both persistent and non-persistent rainfall is something decreasing, but in the central eastern part of China and the southern China, it's increasing. So that's the main features. Sorry. And this is a trend. We look at the ratio of persistent rainfall compared with non-persistent one. You also see a similar pattern, and only say in this part is decreasing. That means, say, persistent rainfall is contributing. Non-persistent extreme is, say, for northern part of China, southwest part of China, it's increasing something like for persistent rainfall, more increasing in this part and other part of China, especially eastern China, southern China, and northeast part of China, and the northwest part of China. And also, you look at the figure, you see here, and this part actually is for the non-persistent one. Red color is for the persistent extreme, and this is the ratio. Then you see for North China actually decreasing. You see the rate also decreasing, but for the South China, okay, sorry. Say for the South China and East China, you see the persistent rainfall is increasing. The ratio of persistent compared with non-persistent also increasing. There are only two places. One is North China, another southwest part of China is decreasing. This is a conceptual figure showing the changes of non-persistent to persistent extreme rainfall in China. You see different regions. I gave an example here, say for the southern China, persistent rainfall increasing, and non-persistent extreme rainfall also increasing. We are facing a shift from persistent to persistent extreme rainfall, and compare with non-persistent extremes. So in the future, in this area, especially in central China and the southern China, and we're tuned to have more total extreme rainfall, which is more contributed by the persistent extremes. But in other two places, mainly dominated by non-persistent, extreme precipitation. And then we look at what's the linkage to the changing of large-scale circulation. Say in China, we have knowledge, say China's rainfall is influenced by many weather systems. One is a subtropical high, which is very important, and we call the Western Pacific subtropical high. Another is the East Asian monsoon here. And this part we have India to, to the Myanmar part of the have low system here. And in the high latitude, blocking systems are very important. If we have we have a persistent extreme event during eastern part of China. So that's the main system in China. And we have studied, look at the contribution to the extremes, and mainly two types. One is we call that something like double blocking system influence the extreme event in China, rainfall in China. And you see that's for 200 millibar, this 500 millibar subtropical high double blocking system here. In the lower level, because water vapor is more important, so mainly influenced by subtropical high monsoon and also low system from the Indian Ocean. And another type is we only have one, blocking high here. So that's the main knowledge we have. And then we try to look at the, the changing of the subtropical high and the blocking, and also India, Burma, the trough, and also the monsoon changes. At the same time, because we want to look at the linkage with the water vapor flux, we try to look at the stationary wave and the transient changes of the water vapor flux. And this is a figure showing actually there are some trends in changing the intensity of the subtropical high in China. In West Pacific, you see mainly the intensity of the tropical high is increasing. Also, the ridge is more extended to the west part of China, and also the location of subtropical high is changing, and more, profoundly you see the blocking system in three regions is increased, and also the trough in the low latitude and the monsoon are weakening. So that's you see a lot of changes also in those systems. Circulation system influence China's extreme rainfall. And we try to use SVD analysis to look at the main patterns of the change of the extreme rainfall. So you see the patterns very similar. One is North China, and another southwest China, and you see pattern positive, negative, positive here. And for this pattern, you see more link to the changing of monsoon and the low latitude, the trough, and also the intensity of subtropical high. For the another pattern you see more on the south part. One is one is positive in the eastern part, the negative in the western part. You see mainly linked to the position of the subtropical high. So those are also the patterns you see. When the rainfall, extreme precipitation change pattern is linked to the circulation changes by an interannual and even in the trend. The variability you see very, very clearly. Under those figures, we try to decompose it to the water vapor flux divergency, based on the 1 day, we can, calculate the transient part, and also we get the low frequency part, which is something like from 2 to 5 days. And this is a way of calculating. Say here you see those water vapor flux was consistent with the changing of the extreme precipitation, both by interannual and long-term trends. And we say here we gave a list for North China, and for Southwest China, you see the transient part is increasing, which is we have more divergent of water vapor. And then we have reduced the non-persistent extreme precipitation and have also reduced the persistent extreme rainfall. And for Yangtze and southern China, that's the opposite. So both can reflect in the water vapor by transient component and the low frequency component. And now we want to look at a specific case for the southwest part of China, because in China some areas have very typical rain periods, and we want to look at are there any duration-based structure change, because we already know southwest part of China is decreasing for both non-persistent and persistent rainfall. So we want to also further to look at the relationship between such change and the ongoing drought and the flux. So in China, southwest China, it's normally we have a lot of precipitation. However, during the recent decades, we witnessed very frequent severe droughts during the past decades. And say you see the loss, how much loss here? 1 year can be US 2.5 billion worth of crops were damaged because of the drought. And for this region, you see we have based on 144 stations. And these are the trends we calculated for the annual rainfall. You see decreasing in the area, especially after 2000, and the temperature increasing very quickly, which is something at decade 0.1 degrees Celsius there. And we'll look at the figure based on a study by Solina and in Europe. So in Solina research about the rainfall structure, say Western Europe area is we're facing more persistent rainfall in the future. However, in southwest of China, say we're seeing increasing of the short duration rainfall and about decreasing the long duration rainfall. And that creates a background for the drought here. And the trend, and here, and we also gave the fractional contribution of the wet spell to the rainy days. And those are the special, we see, the trend of different durations of in the region. And this figure is showing mainly for the different seasons of the changes. You see, especially, say, after 1990, you see decreasing very dramatically for the rainfall you see in the annual rainfall. And those are the trends, especially more obvious in autumn season. And this figure is linking to the change of the different intensity and the different durations, and for such changes, say we get the conclusion as more heavy extreme rainfall falls into the short duration wet spells, while the longer persistent precipitation have less chance to see heavy precipitation. And the mean intensity of the short duration rainfall increase significantly, while the long persistent extreme become weaker. So that's the main conclusion. So simultaneously, we see increase in the short persistent extreme precipitation and a long-lasting drought in southwest China. So this is changing of the extreme durations linked to the changing of the drought in China. Here is the similar conclusions. And say what we have some discussion here, say if such change in the persistence of extreme precipitation is associated with global warming and it can be contributed to human influences, it's still a challenge. You see, that's we have special pattern, and also we have to link to the changing of the circulation, and we also have to, rely on the model performance. And another question is if such structure changes linking to the changing SSC pattern or even land use, because you see two regions in North China, Southwest China, they have different features compared with the whole China. And that's some of our studies published. So my talk will be here. Thank you.
Thank you, Panmao. We have a few minutes for possible questions. And I will start my question, listening to you that the circulation seems to be important. You also said that it is difficult to attribute the change to the warming. And so my question is about, do you have an idea how much this change are linked to the circulation change? Do you have a rough idea how many percent?
So you see, these patterns mainly can be explained by the change of circulation pattern. But in circulation pattern, you also see the trends. So behind may be linked to the global warming. But, this still, we need to further look at this. Because, if only based on the water vapor increase, then you can see the global picture. But here you see regional changes. I think linked to the monsoon, linked to the subtropical high blocking systems in China. So I think, say for this, we have to further look at the model the simulations in the future.
Okay. Any other questions? Yes. And before you answer the question, and also anybody who raised the question, there should be a microphone close to you, if this is the case. And then you take your microphone, if you have one. If you don't have one, you raise your hand, then I will give you a microphone. Because we have people watching this event through website also. So in order for them to listen to your question. So anyway, I repeat your question so the people in the participating through website know what you have asked for. So the question was about the trend. What kind of statistical method you use to detect the trend and also make sure the trend is statistically significant?
That's mainly based on the, for the linear regression, but we linear regression, and we want to see the special patterns of the trend in the country. But when we go to the region, when we have time series, we also consider the interannual variability. Otherwise, you cannot get the result for SVD contribution and for the other analysis.
Okay, but I guess your data are not always normally distributed. So what did you do in that case?
We based on station.
Okay.
Thank you.
Okay. Could you have one more question? The last question, if you have one. Yes. Use the microphone, please. Yeah, you have to push the button. Yeah.
Right, okay. Now I have a question about your definition of persistence. So you have daily resolution station data, and you said, I think, that persistence is when you have more than 1 day.
Yeah.
But with the daily resolution, you would tend to have events also crossing the sharp interval when you go from one day to the other. So
yeah.
Would it be better? Would you get different results if you left out 2-day precipitation event and started persistent event from 3 days?
Yeah, we have different studies. One is based on 3 days, and then we also have 2 days because we want to see the large scale changes. And also we're more focused on extreme part, not only like a 1 millimeter per day event.